Hello everyone. We are going to do some review today of zero and negative exponents. So let's start off with number 1. It wants to know what is the value of 3/4 times 2/3 to the 0 power. Remember, according to PEMDAS, we always want to do exponents before we multiply. So we're going to take care of the exponents first. 2/3 to the 0 power. Well, anything to the 0 power is 1. So we are just going to do 3/4 times 1. And 3/4 times 1 is 3/4. Let's look at number 2. Number 2 is saying to take -6 and raise that to the -2nd power. Well, let's ignore the negative in front right now and just deal with the negative exponent like we were already taught. When you have a negative exponent, you move its position. If it's in the numerator, you move it to the denominator, and if it's in the denominator, you move it to the numerator. Since right now it's in the numerator, because this is really over 1, we would move -6 to the bottom and raise it to the +2nd power since we moved it. Now it's the negative exponent that we're changing, not the negative in front. When we move something with a negative exponent, it's the exponent that we change from negative to positive. So just put the 1 up top. 6 squared is 36, and we make it negative. The reason this does not change to a positive 36 is because I want to show you that these do not equal each other. These two do not equal each other. This is saying 6 squared and make it negative, where this is saying take -6 and square it, and then the negative times the negative would be a positive 36. So with this question, we are squaring the 6 and then making it negative. So the final answer is -1/36. 2 to the -3rd power, very similar to the question above. The only difference is the 2 is not negative this time. So we're still going to take it, move it to the bottom, and make it 1/2 to the +3rd power. Well, now all you have to do in your calculator is do 2 to the 3rd power, unless you can do it in your head, 2 times 2 times 2, which happens to be 8. So final answer is 1/8. Number 4, -2 raised to the -3rd power. Same as the question above. Right now, it's over 1. So we do the reciprocal, move the -2 to the -3rd power to the bottom, and make the exponent positive. So once we move it to the bottom, we took it from the top, moved it to the bottom, our exponent becomes positive. And then again, we can just use our calculator. Oh, it's -2 times -2 times -2, which is a -8. So 1/8. Number C, or letter D. Sorry about that. Number 5, 3/4 raised to the -3rd power. Since there's parentheses around the entire fraction, both the 3 is being raised to the -3rd power as well as the 4. So in this case, we need to flip the entire fraction. We have to move 3 to the denominator, 4 to the numerator. So what we are really doing is flipping both numbers to their new position. Then, once we've done that, we can make the exponent positive. 4/3, you can do the whole thing in your calculator just like that to get your final answer. Or you could raise them both separately. 4 to the 3rd power is 64, and 3 to the 3rd power is 27. So you can do them one at a time, or you can just put the whole thing into your calculator and get your final answer. Choice B. Number 6, we are adding 2 to the negative first plus 5 to the negative first. Exponents is before addition, so we have to take care of those exponents. When you have a negative exponent, you move it to the bottom. So 2 to the negative first becomes 1 over 2 to the positive first. 5 to the negative first becomes 1 over 5 to the first. Well, that's just 1/2 plus 1/5. And then at that point, you can just use your calculator to add them together. Remember, you need like denominators if you're going to be adding fractions, so we can't just add them as is. We can either make like denominators and add them, or we can use our calculator. If you use your calculator, don't forget to put your fractions in parentheses for those that don't change it into a fraction right in their calculator. Parenthesis 1 divided by 2, close your parenthesis, plus parenthesis 1 divided by 5, close your parenthesis, and you will get your final answer of 7/10. Number 7 is a quick one if you recognize the fact that both the 5 and the y are raised to the 0 power, and anything raised to the 0 power is 1. You cannot put a variable into your calculator. So this one you could not do in your calculator. You'd have to remember that anything, whether it's a number or a variable, if it's raised to the 0 power, it is 1. Now, number 8 is a little bit different than number 7. Number 8, only the x is to the 0 power. If it looked like this, here both the 3 and x are raised to the 0 power. So the final answer here would be 1. But notice it's different here in number 8. There's not parentheses around the 3x, so the 3 is not included in being raised to the 0 power, only the x. So the 3 remains a 3, and the x to the 0 is equal to 1. Final answer is 3. So you want to keep in mind, when something is raised to the 0 power, like the x here, where here, both the 3 and the x are. Number 9, we're adding 3 plus 5 to the 0 power. Remember, exponents are before addition in PEMDAS, so we want to take care of that exponent of 0. Anything to 0 power is 1. Now we can add and get our final answer of 4. So just remember to follow PEMDAS. Number 10, 8 squared divided by 1 over 2 to the negative 4th. Let's take care of our exponents first. 8 squared is 64, so it's just 8 times 8. You can confirm in your calculator if you need to. Now this 2 is raised to a negative exponent, and you learned with Mr. S a couple days ago that anything raised to a negative power, you have to flip its position. So here, if it's in the denominator and it has a negative exponent, we need to move it to the numerator to make it positive. So I'll bring down my division sign, and I'm going to move it to the numerator and make my exponent positive. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16, and now we can do that division. 64 divided by 16 is 4. Number 11. We need to rewrite this following expression. Here's the key directions though. We have to have positive exponents only. So everything else, or if it already has a positive exponent, keep it where it is. But if it has a negative exponent, we have to move it so that it can change to a positive exponent. So let's look. A lot of students make an error with these coefficients in front. They kind of make it connected to the variable, but they're not. Each is its own separate thing that we need to attack and decide whether we want to keep it or move it. This 6 really has an invisible 1 on it. The A has the -3 and the B has the 2. So the only thing in the numerator that we need to move is A to the -3rd. That guy will move to the bottom. Now down in the denominator, 5 has its own exponent of a +1. We're not moving him. Oh, but the C has a negative exponent and the D has a negative exponent. So both of them are going to move to the numerator. So the 6 stayed where it was, the 5 stayed where it was. Let's see, we're going to go in alphabetical order. The A needed to move to the bottom to become positive. The B stayed up top. The C had to move up top to become positive, and the D had to move up top to become positive. And we're done. We have made everything to have positive exponents. We're going to write the fraction 1/10 as a whole number with a negative exponent. Well, looking at that, I don't see anything with an exponent, but I could take that 10, and I could even do the 1, having a +1 as its exponent, because 10 is the same thing as 10 to the first. Now, if they're asking me this time to make it have a negative exponent, I would have to move it because right now it's positive. So I would move it to the top to make it negative. 10 to the -1st. Number 13. We're going to find the value of 5 times 1/10 to the -2nd. Here, only the 1/10 is being raised to the negative exponent. This 5 has an invisible 1 as the exponent, so we're not going to do anything with that 5. That 5 is going to remain as is. But this 1/10, that fraction with a negative exponent, we're going to flip and make it a 10 over 1 or just a 10 raised to the +2nd power. Since we flipped this fraction, we were able to make the exponent positive. Now, do exponents before we multiply. 10 times 100, which is 500. Choice 1. Number 14. This is like question 11. We need to rewrite with positive exponents only. So we're going to take the same approach as we did up there. We're going to look at everything individually and decide whether it stays or moves. And then the only other thing different than number 11 is we're going to have some simplifying to do. This C is fine, it's a positive exponent. This C is fine, it's a positive exponent. That 7 is fine. Here we go. This is the only one that we have to move to make positive. So we have C to the 3rd, D to the 7th, move this D to the 3rd up top, and then C to the 5th. All right, let's do some simplifying here. We learned several days ago that when we're dividing with like bases, we subtract the exponents. C to the 3rd divided by C to the 5th is C to the -2nd, because 3 minus 5 is -2. And we also learn when we're multiplying, we keep the base and add the exponents. So one more step, we're not quite done here because the directions said positive exponents only. So this C to the -2nd power has to move down. The D to the 10th can stay in the numerator, but that C has to move to the bottom to become a +2 as its exponent. So the final answer is choice 4. Okay, one more sheet. Number 15. We need to find the value of this. This also is a quick one if you recognize that everything in there is being raised to the 0 power. We can do all that work in there, but we're still, whatever that answer is, we're just going to raise it to the 0 power. So I'm fine if you want to jump right to the answer and say, well, that's 1 because anything to the 0 power is 1. So that right there let us know that the final answer will be 1, regardless of what was inside. Number 16, we're going to multiply 4 squared times 4 to the negative third. When we are multiplying, we learned we keep the base, keep that 4. And we also learned we need to add the exponents. 2 plus a negative 3 is negative 1. Now at this point, I don't see that as one of the answers, so they want us to simplify that one step further. When we have a negative exponent, we just move it to the denominator, because this is just like it's over 1, and when we move it to the denominator, we can make it positive. So this would be 1 over 4 to the positive first power, which is choice 3. Number 17, 2 to the negative fourth divided by 2 to the negative third. Sorry, it's hard to see that. It didn't print well at my house. When we are dividing, we keep the base. So keep the 2. And we subtract the exponents. I'm going to put up here to remind us that we added the exponents in number 16. But in number 17, because we're dividing, we keep the base and subtract the exponents. Now, you want to be careful when you're subtracting negatives. It's negative 4 minus a negative 3. So we're adding there, and we get a negative 1. Now, feel free to use your calculator. You absolutely can do negative 4 minus a negative 3 right in your calculator. And we get a negative 1. Just like the question before, I don't see that as an answer, and that's because we have to simplify it one step further. Again, when we have a negative exponent, we move it to make it positive. So it's 1 over 2 to the first power, which is 1/2. Number 18, we need to figure out what this expression is equivalent to. Now, according to PEMDAS, we need to do what's in the parentheses first. So this here is first. 2 minus 4 is negative 2. And we are raising that to the negative first power. We have a negative exponent. In order to make this exponent positive, we have to move it. Now, when we move it, it's going to make the exponent negative. The moving does not impact the negative in front of the 2. When we move it, it only allows us to change the exponent. So we move it to the bottom. The exponent becomes positive, but like I said, it doesn't affect the actual number itself. So that is negative 1/2. 2 more questions, guys. What would this expression be equivalent to? 2 to the negative third plus 2 to the 0 power. According to PEMDAS, we have to take care of the exponents first. So we have to take care of this negative 3 and this 0 first. When we have a negative exponent, we have to move it. So in this case, go from the numerator to the denominator, and once it's moved, that exponent can become positive. And we're going to add to it 2 to the 0 power. Anything to the 0 power is 1. Well, what is 2 to the third power? That's 2 times 2 times 2. You can do that right in your calculator. It's 1 over 8 plus 1, which is, oh, I'm sorry, that is not 1/8. I was thinking times in my head. It's 1 plus 1/8, which is 1 and 1/8, or 9/8. Choice 2. Last one. Which of the following statements is false? 3 to the negative second power, is that negative 6? 3 to the negative second power, is that 1 over 3 to the second power? And choice 3 or choice 4? Well, let me look here. Anytime you have a negative exponent, you'd have to move it to the denominator. So if I'm looking at choice 1 here, that is not correct, because if I would do that work out, I would take that and move it to the denominator to make it positive, and 3 squared is 9. So 1 over 3 squared, 1/9, yeah, that's not a negative sixth. So this one here was false. Well, thanks very much, guys. You guys have a great day. Stay safe and stay healthy, and hopefully see you guys soon. Bye-bye.